Hi, welcome back. Let's have another look at how to find an inverse Laplace transform. So here we have our function f of s. So we know that this here is the Laplace transform. Your variable is s, which means you are working in your frequency domain. You want to convert this expression into f of t. So you want to take it back into the time domain, and your final function here is going to be f of t equals to some value where t is your variable. Now remember, we need to have some kind of strategy when you solve or when you find your inverse. Otherwise, you end up going in circles. So we start with our denominator. You're going to look at your denominator and see whether you can find the form of that denominator on your formula sheet. So if we look at our formula sheet here, we need to find s squared minus 7. Now I've just written this out, rewritten it, so that you can see it a bit clearer, because this is a little bit small for you. So I've written it over here, right? So if we look, I've only written down from number 3 to number 7. If we look at the denominator here, you have s squared minus some number, and you look at all the values on the f of s side, because we are going to move from the right hand column to your left hand column, because that gives you your inverse. And we look at our denominator, we are looking for s squared minus. So we look s squared minus, that means we are looking at either number 5 or number 6, right? So it's 5 or 6. We know also in our denominator, our second term in the denominator has to have a square. Here we do not have a square, because 7, you don't have a perfect square root for 7, right? So what we're going to do is we're just going to change the form of that function. And we're going to write this as s squared. Wait, let me take that one out there. Give myself some space. Always give yourself some space so you can see what it is you're doing. S squared minus, we leave the 3 there. So we need a square on the outside, but we do not want to change the value of that function. And the only way we're going to be able to do that is if we do square root of 7, because the square of the square root of 7 is just 7, right? And that means that we at least have the form of that second term is the same as the form on your table. It means that a in this case is the square root of 7, right? Okay, so now we've got the denominator in the form that is on the table. So we know now that we are looking at either number 5 or number 6, right? Because we've got s squared minus a squared. S squared minus a squared. And a in this case is the square root of 7. Then we move to our numerator. So our numerator in this case is a number. And if we look at 5 and 6, the one that has the number is number 5, right, with cinch. A is our number, but that has to match with what is in the denominator. It means here that we can't have the 3 in the numerator. We have to have the square root of 7. So what we can do is we can say 3 times something over s squared minus square root 7 squared. We need the a in the numerator, and that is square root 7, right? You can introduce it because it's just a number, it's a constant value. And then we would have to compensate by doing that, right? So all you've done is change the form of the function. The value of it is still the same, but the form is different. So then you will see that this piece here is the same as number 5, right? You've got that a in the numerator, and you have s squared minus a squared. So that is number 5, right? So now, because you have that form, you can now write out what your f of t is going to be, your inverse Laplace transform. So f of t is going to be 3 over the square root of 7. And let's just check what that is. So it's going to be sinh at, right? So that's going to be sinh a in this case is the square root of 7t, right? And that is your inverse Laplace transform.